Okay. Section 11.2 on arcs and chords. Keep in mind to keep all your notes together and all your homework together. Make sure that you get those all checked off with me as you go through the process, and make sure that you have everything so that you can get the grade that you need to get. So we're going to talk about chords and arcs today. Chords and arcs today. So we're going to start with a central angle. Central angle is an angle whose vertex is at the center of the circle. An arc is an unbroken part of a circle consisting of 2 points called the endpoints and all the points on the circle between them. An arc. Minor arcs. A minor arc is an arc whose points are on the interior of a central angle. Interior of a central angle. The measure of a minor arc is equal to the measure of its central angle. Minor arc is usually named by 2 points. This is arc BC. A major arc is an arc whose points are on the exterior of a central angle. The measure of a major arc is equal to 360 minus the measure of its central angle. Major arc is always named by 3 points. This is arc BDC. A semicircle is formed when the endpoints of an arc lie on the diameter of a circle. The measure of a semicircle is 180 degrees. Minor arcs may be named by 2 points. This is arc GH. Major arcs must be named by 3 points. This is arc GIH. Okay, so a little bit of review. Remember, the segment addition postulate says that if I want to find the length of AC, that's the length of AB plus BC. Remember, in the angle addition postulate, if I want the measure of angle ABC, I'm going to find the measure of angle ABD, and I'm going to add that to the measure of angle DBC. So because of that, we can also say that we have an arc addition postulate. Okay, so looking again at the arc addition postulate. Okay, the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So the measure of arc ABC is the measure of arc AB plus the measure of arc BC. Okay, here's the important pieces you need to know. Okay, and you can fill in the blanks here. The ifs are these pieces here. Okay, and then I'll show you the thens. Okay, so congruent central angles. So GAJ and HAI. And your letters might be different on yours, so you have to decide how you want to attack that. Move this out of the way. Okay. So congruent central angles have congruent chords. These are the congruent chords. So if I have this, then I have this. Okay, so congruent central angles have congruent chords. Okay. Next statement. Congruent chords have congruent arcs. So if I have 2 congruent chords, then I have 2 congruent arcs. Okay, last one, congruent arcs. If I have congruent arcs, then I have congruent angles, central angles, that is. Okay, so there's your if and then. Okay, so if I look at that, I'm going full circle. Because if I have congruent angles, then I have congruent chords. If I have congruent chords, then I have congruent arcs. If I have congruent arcs, then I have congruent central angles. Okay, so it's a big circular process as you go along. Okay, so if you have a chord and you draw a radius perpendicular to it, what seems to be the case? Well, if I look at it, I have this radius here. If I draw in 2 more radii, I know that those are congruent. Okay, I know that this is a right angle. These two triangles, A and B, appear to be congruent. Okay, to solidify that, I'm going to take part of that blue radius, and I know that it's shared by both of those. So these two triangles, A and B, are congruent by hypotenuse leg. Because they're congruent by hypotenuse leg, then I know that these two segments here and here are congruent. Okay, so going to the theorems. These are important ones. If a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. Okay, bisects the chord and its arc. Okay, if you have a chord and you draw its perpendicular bisector, what seems to be the case? Well, if I draw a perpendicular bisector, can that be a perpendicular bisector? No, it doesn't bisect that chord down there, that red chord. Okay, it's perpendicular, but it doesn't bisect it. The only way that happens is if it goes through the center of the circle. So it has to be a radius or a diameter. So if KQ is the perpendicular bisector, then it has to be a radius or a diameter. It has to be a radius or a diameter. Okay. All right. Applying to some problems here. Okay. I need to find the measure of arc KLF. So here's K to L and over to F. Okay. I know that that takes up 65% of the circle. So 65 over 100 is equal to X over 360. Okay. Cross multiply and divide by 100. Okay. After all is said and done, we'll end up with 234 degrees, which is equal to the measure of arc KLF. Okay. It is a major arc, so it has 3 letters. Okay, next example. Mine's in color, yours is not. Okay, we are looking for the measure of angle FMC. Okay, FMC. Well, if I look at that, that covers these 3 squares. One that's 9%, one that's 10%, and one that's 11%. Okay, that adds up to 30. So 30 out of 100 equals X over 360. 100X equals 30 times 360. Divide by 100. Okay, X ends up being, I believe it's 108 degrees. I'll double check on my calculator. I believe it's 108 degrees. Let's double check. Let's see. You double check with me, please. Yep, 108. Okay. And that's the measure of angle FMC. Okay. Now I want the measure of arc AHB. Erase this. Okay, I'm going to find the measure of arc AHB. Okay, now I could go through and do it the same way that I just did the previous problem, but I noticed something. It's covering everything except for the rock section, which is 25%. That rock section is 90 degrees. Okay, that rock section is 90 degrees. So that means that the measure of AHB has to be what's left to get 360. So it's 270 degrees. Okay, last one. We need to find the measure of angle EMD. Okay, country covers 10%. So 10% of 360 is 36. So that's the arc. So that means that the angle is equivalent, or 36 degrees. Okay, a few more application problems. Remember, congruent central angles means congruent arcs. So as I look at this problem and seeing how to do it, I notice that this is 97.4. Okay. If I look at it, these go through the center here, so this one will have to be 97.4. This one here, I don't know. But I do know that 97.4 plus that unknown plus 52 is going to give me 180. So I'm going to add those up. Okay, I'm going to add those up. That gives me let's see, 149.4 plus x equals 180. So that means that that missing value there is going to be 30.6. Okay, so that's going to be that missing one. So I'm going to take that 30.6, I'm going to add it to the 97.4 because I've got to find the measure of arc BD. Okay, that's my minor arc. So if I add those together, I get 128 degrees for the measure of arc BD. Okay, next one. Find the measure of arc LJN. So here's L through J to N. Well, I don't know any of those angle measures or arc measures, but I do see that the two central angles there for LPM and MPN are 40 and 25. So I know that LJN has to be equal to 360 minus 65. So the measure of LJN is 295 degrees. Okay, two chords. I know that the circles are congruent and that the central angles are congruent. That means that the chords are congruent. So 14t minus 26 equals 5t plus 1. Add 26, 14t, oops, 14t equals 27 plus 5t. Subtract your 5t. So 9t equals 27, and t is 3. Not done yet. Got to find nm. So nm is 5 times 3 plus 1. So nm is 16. Okay. Last two problems, most important two on here. You will get these wrong if you don't do what it is that I ask you to do. Okay. I need to find the distance from N to P. Okay. I have a perpendicular. I know it's going to bisect because it's going through the center of the circle. So these two segments, once I get one of them, I can double to get the other one. I cannot go anywhere in this problem if I do not draw in the radii from RP to RN. Okay. The distance from R to M is the radius of the circle. That means that RP and NR have to be, or N, excuse me, have to be the same. Those are all radii. I know the distance from R to S is only 8. I know the hypotenuse of that small triangle, RSN, is 17. So I've got to find from N to S. Okay, you can use the Pythagorean theorem, or I know that that's an 8, 15, 17 right triangle. So NS is 15. All I do is double it to find NP. So NP is 30. Okay, you've got to draw in those radii. If you don't, you're not going to get the problem. Okay, last one, same thing. Okay, I know that PT and TS are 10. Together they make the radii of 20. So PR and PQ are each 20. Okay, in order to find this value right here, I'm going to have to use the Pythagorean theorem. So 20 squared equals 10 squared plus x squared. 400 equals 100 plus x squared. X squared equals 300, and x is the square root of 300, which is 17.3. Okay, I've got to double it to get QR. So 17.3 times 2 is going to give me 34.6 for the measure of QR. Okay, for the measure of QR. Okay, so that's 11.2. Remember, notes and homework count as something, so don't forget about them. Make sure that you have them and that they're important to you and that they mean something.